I'm going to show you how Tom's underlying machine works. Here I've got the same program for the simple loop as in the previous video, and if we go to views and click on machine, here we have the underlying machine. This is the memory copied into this area at exactly the same values as we have on the main screen, and we have an address decoder here, we have the registers here, something that indicates which cycle of the clock we're on, and a instruction decoder and an arithmetical logic unit. So when we run, the value of the program counter is sent to the address decoder by opening the address decoder and the program counter to the bus at the same time. This allows the value from the program counter to pass along the bus into the address decoder. You can now continue, and the contents of the program counter has now passed into the address decoder. The path between the program counter and the address decoder is now closed. The address decoder now identifies the memory cell given by the address. The memory location and the identified address is connected to the bus at the same time as the instruction operand registers, allowing the instruction operand pair to be transferred from memory. The gateway between the instruction register and the bus is now closed. The contents of the operand register are sent to the address decoder by opening the address decoder and the operand to the bus at the same time. This allows the value from the operand to pass along the bus into the address decoder's input register. So we can see the value 16 here. The contents of the operand has now passed into the address decoder. The path between the operand and the address decoder is now closed. The address decoder now identifies the memory cell given by the address. So here we can see the address at location 16 is identified. The address decoder now identifies the memory location at the address given by the operand and connects the address location to the bus. So this value can now come down into the register here. The gateway between the general purpose register and the bus is now closed. The load accumulator instruction is decoded by the instruction decoder into the simple action of copying the contents of the general purpose register to the accumulator register, which you can see here. The contents of the general purpose register are copied to memory. For most instructions this is a redundant operation, but we do need to have a write to memory operation within the cycle, otherwise the program could never change memory. So sometimes that is important and sometimes it's a null event. And now the program counter is incremented and it all starts over. So that's basically how the machine works. A very, very mechanical process, but extraordinarily powerful. Thank you.